My name is Gene Carter. I'm an International Product Manager for NXP Microcontrollers. So I'm going to tell you about the NXP portfolio. This session is about USB made easy, how to do USB in just a few clicks. So I'm going to give you an overview of our portfolio of USB parts. Then I'm going to turn it over to Paul, who will go into more of the details on how you can actually implement the USB in a very easy way. So first, I'll discuss the portfolio, and then Paul will go through on the on-chip drivers that are on each of the latest USB parts, and these are actual USB drivers that each of the different classes, and then a free NXP USB lib, as an NXP library that's free for you on our USB parts, and then go over the NXP tools. Okay, so what is NXP microcontrollers? If you're familiar with our stuff, you'll see that they all start with LPC. So LPC equals microcontrollers for NXP. What we've done is try to make them as easy to use as possible. And we do this by having reusing the hardware over and over again as much as possible. So that gives you pin-compatible microcontrollers, so you can move from one part to another very easily without even changing your board. We give you flexible memory size and peripherals within the same pinout, in some cases ranging from 32K all the way up to 512K of flash without changing your part. And then within the same pinouts with LCD controllers, without LCD controllers, with USB, without USB. So if your application doesn't need a certain peripheral or you're doing different variations of the same application, you don't have to change your PCB, but can offer different features to your customers. And then software-wise, we're 100% ARM-based, so use the same tools for all of our parts, same debuggers. Code reuse for most of the parts is as simple as recompiling, and you can run it on a different core. And we also give you the full range going from very low performance up to high performance. So if you want to save on cost or power, you can go for the lower end, higher performance, go up to the higher end. And then it's ARM, so there's a broad base of tool support out there, anywhere from completely free to the Cadillac high cost. It all depends on what you want, but because it's ARM, there's so many choices out there. Choose what's right for you, the right amount of support, the right amount of cost. And that bottom, just want to highlight that for you. Right there at the bottom, this is you can't really see it from where you're, I'm sure, but it's a small list of the innovation awards that we've won, recognition from magazines, different groups out there, customers as well, just highlighting the amount of innovation that we do within there. So with an open architecture like ARM, you really have to differentiate yourself. We've been doing ARM for 10 years, and to differentiate ourselves, we really innovate. Innovate through the way we architect the chip, innovate through peripherals, innovate through tools, and support. So we've been recognized in the market by that, and I think if you work with our stuff, you'll see how we differentiate from some of the competition. So, as I mentioned, we are 100% ARM, complete ARM Cortex range from M0, M0 Plus, M3, M4, and it ranges from these very small LPC 1102 2x2 millimeters all the way up to these dual-core Cortex M4, M0 parts that operate over 200 megahertz. So a pretty broad range of Cortex parts that are available right now with a huge range of peripherals. So getting into the details a little bit more, we start off with the LPC Go family. So this is really our more entry-level parts, very low power, very easy to use, really meant to go after the 8-bit market. So these are at price points below 50 cents for 10K quantities, USB parts below $1 in 10K quantities, so very aggressively priced, very low power, and very easy to use. And then moving up to the LPC Connect, that's where we now add a peripheral such as CAN or USB or something like that to give you a little bit more connectivity to your application, but still a pretty simple to use part. Connect Plus adds more peripherals to that, so that will be where you'll get, say, Ethernet, USB, and CAN all on the same chip. Be able to do different protocol bridges, be able to use different things, and a lot more performance. So these parts go up to, say, 100, 120 megahertz. Then there's LPC Connect Turbo. And then what that brings you is even more performance and even more advanced peripherals. So that's where you'll find things like high-speed USB, That's where you'll find performance up to 200 megahertz, and that's where you'll find the dual-core parts. And then finally, there's LPC Command. That is our ARM9 portfolio, so if you need to run full Linux, you need the MMU support, we have a couple series of ARM9 devices for there. So pretty broad range of ARM devices, and like I said, we've been doing it for 10 years, so we've done a lot of innovation. We have a lot of knowledge in the ARM world. But this class is about USB, so if you just pare that down into the USB world, we have over 100 different USB part numbers. Now, this is not part package combos, this is actual USB part numbers in our portfolio. So as you can see, we range from a very broad, whether it's full speed or high speed, whether it's host device or on the go, whether it has how many ports it has, and whether it has a PHY. We have a huge number of choices for you. So if you're doing USB, if we don't have the option for you, it'll be pretty rare. We have pretty much what you need in the USB 2.0 range. If you're going up to USB 3, then that's a little out of our range right now. So I'm going to highlight 3 different series. We have, as you saw, many, many series, but I'm going to highlight 3 of the latest ones. So if you are familiar with NXP, you'll at least have a little idea about what the latest and greatest USB parts we have. So the USB 11U series is our Cortex M0 line of USB-equipped microcontrollers. The U3 series is the latest version. So what that brings you is higher flash memory, so these go up to 128K of flash, a little bit more RAM, up to 12K of SRAM. They have true double EEPROM, so up to 4K of true double EEPROM in there for storing configuration or serialization data. These come with the ROM drivers that Paul will talk about. And in addition to those, they have some other drivers in ROM, such as a 32-bit divide library. So Cortex M0 does not have a hardware divide. To get around that, we've developed a very, very fast software divide, and we put that in ROM. So it's as simple as you just calling an API, and you get access to that divide. You don't need to fiddle around with anything on that. And then we also have APIs for power profiles and double EEPROM to make it very easy to use. But the power profile is something unique to NXP. We have a very low power, we put it in the lowest power mode, you can put it in the highest performance mode, or you can put it in an efficiency mode in between. And they're all just as simple as just calling an API to make it do that. You don't need to look into the registers, you don't need to play around with things, and we even handle a few things that you can't do, that we don't give you access so you don't get completely into the weeds. We handle all that very easily, so it's very simple to get the power consumption or performance that you want just by making an API call. And then, of course, these parts have all the serial interfaces in addition to USB that you'd expect, the SPI, SP types, the I2C with Fast Mode Plus, USART with a smart card interface. So a lot of nice serial peripherals in addition to the USB with that. And then we have some analog in there. There's a 10-bit ADC with 8 channels multiplexed on there. And then for packages, it ranges anywhere from an HVQFN33 up to an LQFP64. And I mentioned about the pin compatibility. We have M3 pin compatible versions of this as well. So if you need a little more performance than you can get out of an M0 without changing your board, you can move to a Cortex M3 LPC134X part. So the 134X is a 72 megahertz as opposed to the 50 megahertz M0. It has up to 64K of flash memory, up to 12K of SRAM, just like the M0. And it also has the true double EEPROM. It also has the ROM drivers, so as you can see, there's a lot of overlap on those parts. Same serial peripherals. One difference between the two, though, is this has a 12-bit ADC. So as opposed to the 10-bit on the Cortex M0, you've got a 12-bit ADC with 8 channels. And same packages and pin compatible with the M0. And then the third part that I'm going to highlight for you is the LPC 1800 series. So this is one of the Connect Turbo parts, so 180 megahertz performance, up to a megabyte of flash. And that flash is in dual bank, so you're able to write to one bank of flash while continuing executing in the other bank. Or you can just treat it all as contiguous flash if you want. Very large SRAM, so up to 200K bytes of on-chip SRAM. It has a unique NXP peripheral called SPIFFE, SPI Flash Interface. And what that allows you to do is connect to external SPI or quad SPI flash, and it appears in the memory map of the CPU. So as far as the CPU knows, it appears as if it's on-chip flash. So you can add megabytes of very inexpensive serial flash. You can execute from it. It appears in the memory map. So it's a very nice alternative if you need a lot of flash to be able to hook it up very cheaply. It's cheaper than parallel flash and it's faster than parallel flash for the executing. So it's very nice, and this is a unique NXP peripheral. Another unique NXP peripheral is a state configurable timer, which marries the idea of events and states with a timer. So when you hit a certain event, you can put it into a certain state and generate very flexible, very configurable waveforms. So these two features are unique to NXP. They're very configurable, very flexible, help solve problems that maybe you haven't been able to solve with other microcontrollers. This part also has two high-speed USBs with an on-chip high-speed PHY. And it's pin compatible to our dual-core Cortex M4 M0 part. So again, if you need more performance, you need some of the additional peripherals that are on the 4300, without changing your board, you can move over to it. And then it's got a huge number of other peripherals, such as LCD, Ethernet, more DACs, more analog stuff, 8-channel DMA. You can see a huge number of peripherals. So this is a much higher end part than the 1300, but if you need high-speed USB, you need extra performance, this is a very good series to go to. Okay, so that's the portfolio. I'll now turn it over to Paul, and he'll show you how to actually use these parts.
Okay, so USB development has always been pretty difficult. It's, very complex. It takes a long time to develop code. You have to learn the USB protocol, then develop the code for it, and it creates very long development cycles. It also costs a lot of money. You can buy your stack or create your own. That all costs money. Microcontrollers also creates a lot of uses a lot of code space. You also have to worry about things like USB certification and buying vendor IDs and product IDs. So we're going to go over how NXP has helped resolve a lot of these issues. The first thing is USB on-chip ROM drivers. So the boot ROM contains USB drivers to simplify the USB development. So of course, with the code in ROM, it's going to save you a lot of code space. For example, an 1830 doing a high-speed generic HID example using the NXP USB lib, which we'll be talking about shortly, in the LPC Expresso environment with no optimizations. Without the ROM drivers, it takes about 32K. With the ROM drivers, it takes about 23K. So it saves about 8.5 kbytes of code space. So the significant amount of code space can be saved by using the on-chip ROM drivers. Also, using the ROM drivers, of course, you know that these are going to be done correctly. And if you go for certification, you're probably not going to fail. USB drivers, depending upon the device. So the different devices do have different ROM drivers in them, depending upon which, when they were developed. So the first versions of the parts only had HID and mass storage class, but since then we've added things like CDC, which is your virtual COM ports. We, of course, have human interface device and mass storage class device. Some of the newer ones also support composite classes, so you can use the HID and the mass storage from the ROM drivers. You can also do in-system programming using mass storage. So not really using the mass storage class, but it actually has on-chip programming using in-system programming. So I'm going to demonstrate that. So basically what it's going to do is enumerate as a mass storage device. So that's what you'll see on the screen there. So it's going to come up as a drive named CRP disabled. And it's going to have a file on it called firmware.bin. Okay, so that's what it's going to come up with every time. And then what you do is you erase the firmware.bin file, and then you drag a new image onto the drive. and then you reset it, and it'll come up as a new device. So we're going to demonstrate that. Okay, so it's this 1347, and we're going to put in an LPC Expresso board. That's going to make it easy to have access to some of the pins we're going to need to put the device into ISP mode. What the bootloader does is it looks at port 0.1, and it says, okay, is 0.1 low? I'm going to go into bootloader mode. And then it says, okay, is port 0.3 low or is it high? If it's low, it goes into serial mode. So you can use your UART to program it. If it's high, and it's normally connected to VBus when you're using USB, it'll go into USB bootloader mode. So if I plug it in, so now we have our device. Like I said, so basically now you're in bootloader mode, USB programming mode. So here we have a firmware.bin file. We're going to delete that. And we're going to open up where we have our images. And I have a USB HID device. So I'm going to drag that HID device onto the board. I'm going to hit reset. All of a sudden, the mass storage device goes away. As you can see on the computer, it doesn't show that mass storage device anymore. But if I open up a HID client, I'll see that we've actually programmed the part with a new image. And that was really, really simple. So this HID device, basically, it's just you program on the out reports. You're just going to set a few bits, and then on the in reports, it's just going to reflect what you've written to it. So pretty simple HID device. Okay, so now, show you again what we can do is just reset it again, put it in bootloader mode. I'm going to take the HID device off. I'm going to put a different mass storage class. Now this is not the ROM-coded mass storage device. So I put it on there, hit the reset. All of a sudden now you see we have another mass storage class device with a little README file on it. So it's a pretty fail-safe way of programming, and it's a lot faster than using serial for programming. So a nice feature built into all the USB parts. Okay, so let's focus now on NXP USB Lib, which is our solution for USB. And what this offers is USB compliance. Host and device modes are built in. And that's both OHCI and EHCI type hosts. It supports low, full, and high-speed transfers. Control bulk, interrupt, isochronous transfer type, so pretty well everything. At the moment, it supports Cal Microvision 4 and LPC Expresso 4. LPC Expresso is code red, so it supports code red as well. IR should be out any day now. I wouldn't be surprised if what you download now has IR support. It is open source, and it's designed to run on almost all NXP LPC microcontrollers. There's just a couple of exceptions, and that is the first generation of LPC 13.4X parts, the 1342, 43. Those will not be added. Other than that, it supports pretty well everything. It does have a few limitations. It can only drive one host or device at a time. As was mentioned earlier, we do have devices with 2 hosts. We are rectifying that in future revisions of the part. We're at 0.97 now, so as soon as 1.0 comes out, we should have dual host capabilities. The host only supports one device at a time, and there's no hub support. Again, we're not even at version 1.0, and certainly we'll be adding new features constantly, so we'll fix all these minor limitations. Okay, we already talked about this. It's supporting device, host, and dual host will be coming soon. As far as classes, supports HID, DFU, should be coming soon. Actually, on some we do have DFU already supported, and that's available for download on our website. Supports audio, virtual COM or CDC, mass MSC or mass storage class, and smart card will be coming soon as well. And we have a whole list of different classes that we're planning to support in the future as well. So if customers come up with an idea or a desire to have a new class added, we will put that in, if it makes a good business sense, we will add that to the list for the development. So what's included? Includes a lot of, pretty well everything you need to support USB. So full speed devices, full speed hosts and device, a high speed host and device, soon dual hosts and device, control bulk interrupt and isochronous transfers, all three of the major tool chains that we use. As far as BSPs, so by BSPs, we mean the board support package like this is our LPC Expresso base board here. We also will have the boards like the High-Tex boards for the 1850 and the NGX Explorer board for the 4330. So if we have specific boards, we'll have board support packages for those devices. Included examples, so we have audio host and device. We should have the audio in very soon. Keyboard host and device, mass storage host and device, a mouse, a virtual COM device, and a dual role soon enough. And ROM drivers, we support high speed in the 1800 and 4300 and full speed in the LPC 11U family and the LPC 134X family. So where to get it? When you think of microcontrollers and NXP, think of LPCware. This is where you want to go to get any kind of application notes, peripheral driver libraries, graphics libraries, and certainly NXP USB lib. So this is a nice place to find everything in one spot. Yes?
I didn't see on-the-go support.
What support?
On-the-go?
At this time, we do not have on-the-go support.
In hardware, software?
We have, definitely we have it in hardware. We've had on-the-go support for quite a long time. We do not have on-the-go in NXP USB lib yet. So think of LPCware whenever you want any information on our microcontroller products. That's a great place to go. And also they have a forum which we monitor. So as far as board coverage, here's an eye chart of all the different boards. I'm not going to go through all the different parts that are on that list, but we support quite a few. Here is the different class coverage. You can see all the different devices. So the devices, the LPC 1800s, the LPC 4300 family, the LPC U family, the 1700 family, the 177X, 8X family, the LPC 4000 family, which will be announced, I think it's today, the LPC 1347, and the LPC U2X, 3X family. And then there's also ROM driver support that's in the LPC 1800, 4300, 11U, and 1300 family. Okay, so let's go through an example. It's going to be really easy, basically 4 easy steps to get something up and running on using NXP USB lib. So if we open up LPC Expresso, we tell it where we want the workspace. It's already been defined, where I have my, my libraries. So the first thing we want to do is import the projects. So NXP lib is already, I've already put it in this LPC 1347 folder, okay? So here's a list of all the things in this, all the different projects in NXP USB lib. Okay, so there's quite a few. So you can pull them all in, or you can just choose to pull in what you want. I like to just pull in the files that I want to use. Other people just pull in everything and then just set one of the projects as the active project. So it depends how you like to work it. I like to keep my workspace relatively clean, so I'm going to deselect everything. So the first thing I can choose is a BSP. Now the BSP, you can choose one of the BSPs that are there or create your own, or start with one of those BSPs and then modify that BSP. Of course, we're just going to use the BSP for this LPC Expresso baseboard. The CDL you'll use every time, that's the common driver library. Okay? And I'm going to use a generic HID, and NXP USB lib is something you're going to need every time. So what you're going to need every time is the CDL, an example, and NXP USB lib, and then you can choose to use the BSP or not. Okay, so I'm going to copy these. These will be copied into the workspace. And the first time it may take a little bit of time. Not too bad. And here's the projects we've pulled in previously, the BSP, the CDL, the example generic HID device, the NXP USB lib. Okay, so now we have to configure each of these projects for the device that we're going to use. Okay, so if we right-click, we get a context-sensitive menu. We can just do build configuration, and we hit manage. Okay, then we get this list of all the different things we can use. We're going to the LPC 3 on the LPC Expresso baseboard. So the BSP, this is we're choosing which board we're going to target. Okay, and we're going to set this one as active. Hit OK. Again, now we're going to choose the CDL. And if you pull up manage, we're going to say, okay, which device are we going to choose? So this is the LPC 13 family. Select that as the active device. Okay, so now the example of the HID. So here's, again, you're going to choose the microcontroller that is going to be supported in this project. And again, choose the LPC 13 device. We're going to set it as active, hit OK. So far, so good, right? Pretty straightforward, no questions, okay? And then we go to NXP USB lib. And we are given lots of different options. Here's all the different devices. As you can see, you can be a host or device. In this instance, we're going to be LPC 13. Set that as the active device, and we hit OK. We do need to set one item here and set the indexer to use the active build configuration. Okay. And then at this point, we can build it. That doesn't look right. It says 1300. Oh, missed one step here. We do need to tell it what microcontroller we're using. So choose a microcontroller, make sure it's a 1347, and now that looks right. See, now we see that it's the build example, generic HID, LPC 13. So if we could build this, hopefully get no errors. Okay, so everything built with no problem. So when you take a look at the the 1347 board, there's a target side, which has the 1347, and it has a debugger side. And that has a high-speed ARM9 device on it, one of our microcontrollers. So we're going to need to put a USB cable into the debugger side. Okay, so now we have one on the device side, one on the debugger side. I added one to power the board. So that's why we have 3 cables hooked up to this thing. Okay, so we select generic HID, and we can go into debug mode now. Okay, let's try that. Okay, so it found the debugger. Okay, so it stops at the first breakpoint. And I press go, and you hear the little beep. Obviously, the Windows has enumerated it, and our little NXP USB lib generic HID demo is now functional. Okay, so what we have on this is 3 buttons on it to turn on and off the RGB LED. So we click on the first one, and you see that the red LED went on. The blue LED goes on by clicking the second. So a very, very simple HID example. Only took us a few minutes to do. But modifying a HID example is really, really, really simple. So basically all you do is you take your out reports and do something with the data that was sent by the PC to the device. One thing you can change on is the configuration file. So on the configuration file, you can actually change the, at the bottom, you'll see number of ports. So on the 1800, 4300, we have 2 ports, right? So this allows you to go to port 0 or to port 1. Use the ROM stack or not. So you don't have to use the ROM stack if you don't want to, but if you set this to 1, it'll use the onboard ROM stack. You can also force full speed. So if you like in USB audio, which uses full speed, you can actually force the high-speed controller into full speed mode. So it does have some switches in the NXP USB lib configuration file. This is a relatively new program that we established, and it allows you to get up to 3 free PIDs. Okay, so now you're not having to spend all that money to get PIDs. Now in the past, you were able to buy some PIDs online. People would buy a vid and then they would sell you 10 PIDs. The USB organization has shut those down, as far as I know. I know a few people who were doing it, and USB went after them and shut that down. That was not a legal process, a legal way to get product IDs. So what we did is we bought a vendor ID, and we got authorization from USB.org to give away 3 PIDs. Okay? And it's very simple. There's a application on LPCware again, and the URL is listed there. You download it, you send it in, and we give you our vid and 3 PIDs, saving you lots and lots of money. Because if you take a look at this, you know, there's different levels of within the USB organization. You can be a member, and that costs you $4,000. You can become a non-member, but you want to go for a logo license, and the licensing fee is $2,000. That's if you want to use the logo on your products. But the bottom one is if you just want to purchase the vendor ID without signing the logo license agreement, the administration fee for this is $2,000. And you don't have to execute the logo license agreement. And supposedly you're not authorized to use the USB logo in conjunction with your products regardless of the testing status. So at the beginning, we are just doing the LPC 11U family. Okay, so we're just getting started in this. We're just seeing how it goes. So we're just going to pick one family, and that's the LPC 11U. USB IF membership is not required for this. One of the restrictions is that we don't want you to use it for high volume type production. So anything over 10,000 units, we feel that you should get your own vendor ID, right? So this is mainly used for the smaller type projects. And of course, this allows you quick time to market. You don't have to go through the process of, getting your vendor ID and paying your $2,000 and everything. So again, quick time to market, saving you cost again. So the one thing is you can submit a product using the NXP VID and PID to compliance testing to qualify for the certified USB logo. Okay, so if you want to pay the extra money to get the logo, you can still do that. All you need is prior written authorization to use the VID from NXP at the time of registration of your product for the USB certification. Well, your authorization is obviously that little, sheet of paper we send back to you with your PIDs. So that should be good enough, I would think, for that. And also you can use it for the purpose of verifying or enabling interoperability testing at, PlugFest and things like that. So it's a pretty simple program. Just a little sheet of paper you need to fill out. There's a lot of FAQs on our website, right? Because there's a lot of questions regarding this program that I haven't covered here. So please go to LPCware and check out the FAQs. We kind of try to go through all the different questions that the customer could ask, and we've got a pretty good FAQ site there. So the bottom line is NXP is the one-stop shop for USB. So because we do have the widest range of microcontrollers with USB, we offer full speed, high speed, device, host, dual host, as well as OTG hardware. These devices have been certified at USB.org. We do have the free USB stacks, NXP USB lib, as well as other stacks. We have examples codes from our major tool vendors like Kyle and IR have examples for our products as well. We have the on-chip ROM drivers. Of course, that's going to save you a significant time as well as cost and code space. And now we've offering the free PID program to save you a couple of $1,000s there.